Good evening, I am Hannah Leynes, and today I will be discussing a spread spectrum techniques and types. So again, I am Hannah Chrisselle Leynes, and this is a coursework under the course ECEA 111-1, section E06. So now, what is spread spectrum? In here, it is defined as when inserting the code or sequence that is attached to the communication channel, it expands the bandwidth signal by several arrangements of magnitudes. It is also defined extensively as where RF communication system, where the baseband signal bandwidth by, by introducing a higher frequency signal is broadened over a larger bandwidth. As a result, the transmitting signal's energy is distributed over a wider bandwidth and will result in noise. Typical spread spectrum processing gains run from 10 dB to 60 dB. So we can see a figure 1 here. So to introduce the spread spectrum technique, we need to administer the corresponding spread spectrum code or sequence in the transmitting chain before the receiver antenna. This process is called a spreading operation. The result will be is to diffuse the information to a larger bandwidth, and for this spreading operation, it involves of reconstituting the information into its original bandwidth. In advance, the same code must be known at both ends of the transmission channel. So, what are the benefits of the spread spectrum? Number 1, resistance to interception. Number 2, resistance to interference and anti-jamming effects. And number 3, resistance to fading, which is the multipath effects. So now we will be discussing DSSS and FHSS, which are the types of the spread spectrum. So here, in the DSSS technique, to the data entering the carrier modulator is where the PRN is applied. The modulator observes that there is a larger bit rate, which relates to the PRN's sequence chip rate. To produce a direct sequence modulated spread spectrum with a frequency spectrum centered at the carrier frequency, it needs a modulation of an RF carrier with a certain code sequence. So in this technique, it has bandwidth that has the clock rate of the modulating code, which is the main lobe of the spectrum. It also has a null-to-null bandwidth equal to the clock rate of the modulating code, which are the side lobes. Illustrated in the diagram is the most common type of DSSS, which is a binary phase shift keyed, or also called BPSK, which is used in direct sequence systems. The spectra of the direct sequence differ in spectral shape, which depends on the data modulation and actual carrier used. And the next one is also a type of a spread spectrum, which is called the frequency hopping spread spectrum, which is FHSS. So the FHSS technique results to a carrier to hop from frequency to frequency over a wide band according to a sequence defined by the PRN. In this technique, the data rate of the original information is independent while the speed of the executed hops are dependent. So this means that the measure of the speed of the executed hop depends on the data rate of the original information. This technique allows to execute consecutive bits of data and able to modulate the equal frequency. The fast frequency hopping and the low frequency hopping is distinguished. The FHSS can be distinguished by several hops within each data bit. So the transmitted spectrum of frequency hopping signal is quite different from that of a direct sequence system. Instead of a shaped envelope, the frequency hopper output is flat over the band of frequencies used. So the bandwidth of a frequency hopping signal is simply n times the number of frequency slots available, where n is the bandwidth of each of the top channel. So again, what we've discussed is the spread spectrum, techniques, and types. So our key takeaways, there are two types of spread spectrum, which is the DSSS, or also called as direct sequence spread spectrum, and the other one is frequency hopping spread spectrum. Thank you for listening.